Before we get into the video, if you're truly interested in the cosmos, please watch the whole thing to support me. Thank you very much.
You look up at the sun. You see yellow, but your eyes are lying to you. The sun is white. Every wavelength of visible light leaves its surface at once, blended together into pure white light. Your atmosphere is the one doing the painting. Nitrogen and oxygen molecules scatter the shorter blue wavelengths across the sky, spreading them out until the sky itself looks blue, and the sun, stripped of some of that blue, looks warmer to your eyes. NASA has measured the sun's true color directly from orbit, outside the filter of air, and it comes back white every single time. So if the sun isn't really yellow, what else are you getting wrong? Look up at night. Thousands of points of light, each one a star, some larger than your entire solar system, some burning with more energy in a second than your body will use across your whole life. And yet, between them, there is nothing but black. That should bother you. Here's why. The universe is old. It is vast. By most current estimates, it holds over 1 trillion galaxies, each one packed with tens or hundreds of billions of stars. Multiply those numbers together, and the total starts to feel less like an amount and more like an argument. If you drew a perfectly straight line in any direction from where you're standing right now, that line should eventually hit a star. Every direction, every line, which means the night sky, mathematically, should be a solid, unbroken wall of light. It isn't. It's black. And that contradiction has a name. It's called Olbers' paradox after the German astronomer Heinrich Olbers, who formalized the problem in 1823. But he wasn't the first to trip over it. Johannes Kepler noticed the same unsettling gap 2 centuries earlier and used it to argue the universe couldn't stretch on forever. Even the writer Edgar Allan Poe, in his 1848 essay Eureka, reasoned his way to a piece of the real answer decades before physicists had the tools to prove it. So let's reconstruct the problem the way they saw it. Picture yourself standing in an infinite forest. Trees stretch out in every direction, packed close enough that no matter where your eyes land, your line of sight eventually hits a trunk. You wouldn't see clean gaps of open sky between the branches. You'd see a solid wall of bark, near trees and distant trees blending into one continuous surface with no visible sky at all. Now replace every tree with a star. That's what an infinite, unchanging universe should look like from where you're sitting. Not a scattering of pinpricks in a black field, but a solid, blinding wall of starlight, bright enough to burn your eyes. Instead, you get darkness, which means at least one of your assumptions is wrong. Here's the twist. It isn't that there aren't enough stars. There are more than enough. The real answer is that light takes time to travel, and the universe has not existed forever. Current measurements, refined through data from missions like the European Space Agency's Planck satellite, put the age of the universe at roughly 13.8 billion years. That number matters more than it sounds like it should. It means the light from anything more than 13.8 billion light-years away literally has not had time to arrive at your eyes yet. Those stars exist. Their light is on its way, crossing space at exactly the speed limit the universe allows. You're looking at a universe with an edge, not an edge in space, but an edge carved out of time itself. There's a second piece to this puzzle, and it's just as strange. The universe isn't only old, it's expanding. In 1929, the astronomer Edwin Hubble discovered that distant galaxies are rushing away from each other in every direction, and the farther away a galaxy sits, the faster it's receding. Space itself is stretching, carrying galaxies apart the way raisins in a rising loaf of bread drift apart as the dough expands, with no raisin at the actual center. That stretching does something very specific to light. As a beam of light crosses billions of years of expanding space, its wavelength gets pulled and stretched right along with it, shifted from visible light toward infrared, then further out toward microwave. Light that started out bright enough to blind you can arrive billions of years later, completely invisible to human eyes. Not gone, just shifted into a color you were never built to see. That leftover light didn't vanish. In 1965, two researchers at Bell Labs, Arno Penzias and Robert Wilson, picked up a faint, constant hiss of microwave radiation coming from every direction in the sky at once, with no source they could identify or point a telescope at directly. What they had stumbled onto was the cosmic microwave background, the stretched, cooled afterglow of the universe's very first light, radiation that began as a blinding flash roughly 380,000 years after the Big Bang and arrived at Earth billions of years later as a whisper, thousands of times too faint and too red for your eyes to register as anything except black. The physicist Georges Lemaître had proposed the idea of an expanding universe with a fiery beginning back in 1927, years before Hubble's observations gave it hard evidence. For decades, it competed against a rival idea called the steady-state theory, which pictured the universe as eternal and unchanging, quietly creating new matter to fill the gaps as it expanded. Steady-state could explain a lot. It could not explain that faint microwave hiss. The moment Penzias and Wilson's discovery was confirmed, the steady-state model collapsed almost overnight, and a universe with a beginning, and therefore an edge in time, became the accepted picture. So the sky above you isn't empty. It's completely full. It's just speaking in a wavelength your eyes were never designed to receive. Now widen the picture even further. Imagine you could turn a dial and boost the sensitivity of your own eyes, the way a telescope operator boosts exposure time on a camera sensor pointed at empty-looking sky. In 1995, engineers at NASA aimed the Hubble Space Telescope at a patch of sky so small and so dark that astronomers privately worried it would return nothing at all, just noise. They left the shutter open for 10 consecutive days. What came back was the Hubble Deep Field, not a blank frame, but nearly 3,000 galaxies crammed into a sliver of sky no wider than a grain of sand held at arm's length. The darkness had never been empty. Your eyes simply didn't gather light long enough or well enough to see what was already there. That's the real lesson hiding inside a dark sky. Blackness isn't nothing. It's a signal your senses failed to catch, either because the light is too old, too faint, too red, or because your eyes only integrate a fraction of a second's worth of photons before moving on to the next thing. A telescope doesn't see more than you because it has better eyes. It sees more because it waits longer. Think about what that actually means the next time you step outside after dark. The blackness above you isn't the absence of light. It's light that arrived too old, too stretched, and too dim to count as visible anymore. Every patch of that darkness has photons moving through it right now, ancient and silent, aimed directly at your face. You're standing inside a fossil record written entirely in light, and your eyes can only read the very last faded line of it. It changes how you look at the daytime sky, too. That warm yellow disk you've been staring at your entire life was never really yellow at all. It was white, filtered through 100 kilometers of your own atmosphere before it ever reached your retina. Your eyes have been editing reality for you since the day you were born, trimming down an overwhelming universe into a version simple enough for a human nervous system to process without breaking. You looked up at the sun and saw yellow. Now you know it was white all along, and the darkness sitting right beside it, the darkness you assumed was simply empty space, was never really empty at all.